When installing low-voltage dimmers for fluorescent recessed hi-hats, it is essential to properly splice the low-voltage control wires to the ballast within a junction box at each fixture. Fluorescent recessed hi-hats commonly use electronic ballasts, which operate on 120 volts alternating current. Low-voltage dimmers, such as 0 to 10-volt dimmers, cannot directly control the ballast power supply. Here's the recommended installation process. Firstly, install junction boxes at each fixture location. Secondly, extend the control wires from the ballast through the junction box. Thirdly, splice the low-voltage wires from the dimmer to the control wires of the ballast inside the junction box. Fourthly, connect the 120 volts alternating current power supply to the ballast. Now for safety considerations, ensure the installation meets all applicable electrical codes and regulations according to the 2014 National Electrical Code. Verify that the low-voltage dimmer and ballast are compatible with each other. Properly ground both the junction box and the low-voltage system. If the junction box is not located within the fixture, ensure it is accessible and properly enclosed to protect it from moisture and debris. In the 2014 National Electrical Code, several articles pertain to the proper installation and safety of lighting and control systems. Article 410 covers luminaires, lamp holders, and lamps, and provides requirements for the installation of lighting fixtures, including recessed lighting. Article 300 addresses general wiring methods and materials, outlining the requirements for wiring in electrical systems, including the use of junction boxes. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits, which are relevant to low-voltage control systems like 0 to 10-volt dimming systems. Within Article 410, specific sections address recessed lighting fixtures. For example, Section 410.16 provides requirements for the installation of recessed luminaires, including clearances from combustible materials and thermal protection. Section 410.117 covers wiring of luminaires, addressing the requirements for connecting the power supply and control wires to the fixture. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and manholes. Section 314.16 details the number of conductors allowed in outlet, device, and junction boxes, which is crucial for ensuring the junction box is not overcrowded. Section 314.17 covers the wiring entering and exiting boxes, conduit bodies, and fittings, specifying how conductors should be protected. Article 725 provides requirements for low-voltage control circuits. Section 725.55 addresses separation from power conductors, ensuring that low-voltage control wires are adequately separated from 120 volts alternating current power conductors to prevent interference and ensure safety. Section 725.136 covers the installation of Class 2 and Class 3 circuit conductors, including wiring methods and overcurrent protection. Grounding is a critical safety measure in electrical installations. Article 250 covers grounding and bonding, providing requirements for grounding electrical systems and equipment. Section 250.110 requires grounding of electrical equipment, including lighting fixtures and junction boxes. Section 250.148 covers continuity and attachment of equipment grounding conductors to boxes, ensuring that the grounding path is continuous and effective. Proper conductor sizing is crucial for the safe and efficient operation of electrical circuits. Article 310 provides requirements for conductors for general wiring. Section 310.15 details ampacity tables for conductors, specifying the maximum current a conductor can carry safely based on its size and insulation type. Section 310.16 provides allowable ampacities of insulated conductors rated up to and including 2000 volts. When working with electrical installations, always refer to the latest edition of the National Electrical Code and consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Proper installation techniques and adherence to safety guidelines are essential for preventing electrical hazards and ensuring the reliable operation of lighting systems. Remember, working with electricity can be dangerous. Always turn off the power at the circuit breaker before working on any electrical circuits. Use appropriate safety equipment, such as insulated tools and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. When installing low-voltage dimmers, ensure that the dimmer is compatible with the ballast being used. Some ballasts require specific types of dimmers, and using an incompatible dimmer can damage the ballast or cause it to malfunction. Always refer to the manufacturer's specifications for both the dimmer and the ballast to ensure compatibility. When splicing wires in a junction box, use appropriate wire connectors that are listed for the size and type of conductors being used. Ensure that the wire connectors are properly tightened to provide a secure electrical connection. Do not overcrowd the junction box with too many wires, as this can cause overheating and increase the risk of electrical hazards. Follow the full requirements specified in the National Electrical Code for the maximum number of conductors allowed in a junction box. When running control wires from the ballast to the dimmer, use the appropriate type of cable or conduit to protect the wires from physical damage. Ensure that the cable or conduit is properly secured to the junction box and the surrounding structure. Avoid running control wires in close proximity to power conductors, as this can cause interference and affect the performance of the dimming system. Maintain adequate separation between low-voltage control wires and 120 volts alternating current power conductors. Grounding the junction box and the low-voltage system is essential for preventing electrical shock hazards. Ensure that the junction box is properly grounded to a grounded metal enclosure or a grounding electrode conductor. Connect the grounding conductor from the low-voltage system to the grounding terminal in the junction box. Test the grounding system to ensure that it is functioning properly. After completing the installation, test the dimming system to ensure that it is working correctly. Verify that the lights dim smoothly and consistently over the full range of dimming. Check for any flickering or other abnormal behavior. If you encounter any problems, troubleshoot the wiring and connections to identify and correct the issue. Regularly inspect the installation to ensure that it remains in good condition. Check for loose connections, damaged wiring, and other signs of wear and tear. Repair or replace any damaged components promptly to prevent electrical hazards. By following these guidelines and adhering to the National Electrical Code, you can ensure the safe and reliable installation of low-voltage dimmers for fluorescent recessed hi-hats. Remember that safety is paramount, and it is always best to consult with a qualified electrician if you have any doubts or concerns about the installation. Low-voltage dimming systems, such as 0 to 10 volt dimming, offer several advantages for controlling fluorescent lighting. These systems allow for smooth and continuous dimming, providing greater flexibility in adjusting the light level to suit different needs and preferences. They are also energy efficient, as dimming the lights reduces the amount of power consumed. Furthermore, low-voltage dimming systems are relatively easy to install and maintain, making them a cost-effective solution for lighting control. The 0 to 10 volt dimming system works by varying the direct current voltage between 0 and 10 volts to control the light output of the fluorescent fixture. At 10 volts, the light is at its maximum brightness, while at 0 volts, the light is at its minimum brightness or completely off, depending on the ballast design. The dimmer sends a control signal to the ballast, which adjusts the power supply to the fluorescent lamp accordingly. This allows for precise control over the light level, creating a comfortable and energy-efficient lighting environment. When selecting a 0 to 10 volt dimmer, it is important to choose one that is compatible with the ballast being used. Some ballasts require specific types of dimmers, and using an incompatible dimmer can damage the ballast or cause it to malfunction. Refer to the manufacturer's specifications for both the dimmer and the ballast to ensure compatibility. Consider the dimming range of the dimmer and the ballast. Some dimmers and ballast offer a wider dimming range than others, allowing for greater flexibility in adjusting the light level. Choose a dimmer and ballast that provide the desired dimming range for the application. Look for dimmers that are easy to install and operate. Some dimmers feature simple wiring connections and intuitive controls, making them easy to use and maintain. Choose a dimmer that meets your specific needs and preferences. In addition to the 0 to 10 volt dimming system, there are other types of low voltage dimming systems available, such as digital addressable lighting interface, or dolly, and phase cut dimming. Each system has its own advantages and disadvantages, and the best choice depends on the specific application and requirements. Dolly is a digital communication protocol that allows for individual control of each lighting fixture on a network. This system offers advanced features such as scene setting, energy monitoring, and remote control. Phase cut dimming, also known as triac dimming, is a traditional dimming method that works by chopping off a portion of the alternating current waveform. This system is commonly used with incandescent and halogen lamps, but it can also be used with some fluorescent and light-emitting diode or LED lamps with compatible dimming ballast or drivers. When installing a low-voltage dimming system, it is important to follow all applicable electrical codes and regulations. Ensure that the wiring is properly sized and installed, and that all connections are secure. Ground the system properly to prevent electrical shock hazards. Test the system thoroughly after installation to ensure that it is working correctly. Low-voltage dimming systems can provide significant energy savings and enhance the lighting environment in a variety of applications. By choosing the right dimmer and ballast and following proper installation procedures, you can create a comfortable, energy-efficient, and safe lighting system. Remember to consult with a qualified electrician if you have any questions or concerns about the installation. They can provide valuable guidance and ensure that the installation meets all applicable codes and regulations. Always prioritize safety when working with electricity and take the necessary precautions to prevent electrical hazards. With proper planning and execution, you can successfully install a low-voltage dimming system that meets your lighting needs and provides years of reliable performance. Furthermore, consider the long-term maintenance requirements of the lighting system. Choose components that are durable and reliable, and establish a regular maintenance schedule to ensure that the system continues to operate efficiently and safely. Inspect the wiring, connections, and other components periodically, and replace any damaged or worn parts promptly. Clean the lighting fixtures regularly to maintain optimal light output. By taking these steps, you can extend the lifespan of the lighting system and minimize the need for costly repairs. In conclusion, installing low-voltage dimmers for fluorescent recessed hi-hats requires careful planning, proper installation techniques, and adherence to applicable electrical codes and regulations. By following the guidelines outlined in this video and consulting with a qualified electrician when necessary, you can ensure a safe, reliable, and energy-efficient lighting system that meets your specific needs.